is not going to make it in today, she said, so this may be all of it. 1, 2, 3, 4, 5, 6. I guess I can take it. All right, I got us for 6. If anybody else shows up and I don't acknowledge them, let me know so I can write it down. Dr. Becker had a meeting yesterday for the college, and they are going to get a Respondus monitor for a lockdown browser for tests on Blackboard. So we will be doing tests on Blackboard and not through WebAssign, which I was hoping they would get something so we could do that. I'm not crazy about the WebAssign testing environment. But anyway, I don't know when it's supposed to be here. It's something about a 48-hour contract, and then we get it back. And they said hopefully this weekend something will be up. So we're supposed to have a test next Friday. I will probably make it where everybody has to test in the vicinity of the same time. So I don't want anybody to feel pressure to share information with anybody else. So we probably won't leave it on Friday, but we can talk about that next Monday when they get everything up and running. So we may move it to the next Monday during class time. That would give you an extra weekend too. I know some of you are still treading water to get caught up. Does that sound okay with everyone?
How does the calculator thing work? Because how
Can
does it?
anybody hear me?
Yeah. Hello.
Okay, good. Thanks,
How
Chris.
does calculators work? Because wouldn't it think that a calculator might be a phone?
No, in fact, it records everything you do, and then it flags movement, and then I review it. So it doesn't lock you out. It just flags spots for me to review. So I don't have to watch all 2 hours of your test, 4, 6, 8 hours for some of you in your case. It does make sure that you stay in front of the computer. There's this you have to, before they will allow you to start the test, you have to scan your area, and stuff. But then there's what, no thank you, but I do want some caffeine, please. Then there's, like I said, it flags when certain things occur. There is a facial monitor, like when you're not looking at, like when you're not continually looking at the computer, because I played with it yesterday. I played with it in Alex, which is not quite the same, but it should be similar. There's a facial recognition, and if you look away too much or look down too much, it flags, and then it puts up a dinger and tells you to get back to work or something, or says, you know, you're not watching the screen, something's going on. But I disabled that because, I mean, you guys will look at one question on the screen for 1 minute and then spend at least 10 minutes working on it. So I disabled that part of it. So I don't know. I mean, it's just a work in progress. There's nothing in the program that like kicks you out or invalidates your score. I plan on just uploading regular type questions that I would ask you on a test, and there would be a time limit. And then you'd have the recording on you. So the one thing is you will have to have some type of recording device, but I think that all of you do. If someone doesn't have that computer capability on their device, then I could do an individual Zoom session. There's so few of you, so I'm not really worried about that. The Alex people did say that you cannot get Respondus or the lockdown browser, one of them. There's a lockdown browser also, Chris, so you can't open any other app. You can't record the screen. You can't print. You can't do anything like that while it's on either. But anyway, the Chromebooks cannot download the Respondus monitor or the lockdown browser, one of them. So unless someone is using a Chromebook, they said that's really the only device that they ran into that had given them problems.
All I have to record is a Chromebook.
Oh, well, see, then you would be a problem, but you and I could do a Zoom session separately on even your phone, or actually we could do a Zoom session on Chromebook, so that's not a big deal.
Okay.
Well, get me a water and a strawberry. Yeah.
This is going to be the biggest disaster of the year. I'm just telling you right now.
I have questions on my
why?
test.
What's going on? I just joined.
Blake, they're
Everybody's
taking our
complaining.
computers. They're
Jump
taking our
in.
rights.
What's going to be the problem, Cole?
Government's monitoring us.
Oh, good Lord. I'm sure they don't care what you do on your
Mrs.
differential
Elliott
equation
doesn't trust us. That's what it is.
Just don't
Is
have
that
any
what it
pot plants
is?
behind you when you're recording. Oh, come on, you guys. As if I don't know when Hoplex sends you on a take-home test. You don't all work together and share answers and Zoom and Snapchat.
That was
I
freshman
know what
year.
goes on.
Everyone
my
has check
daughter-
now. It's fine.
Exactly. Everyone has Chegg, and everything's on Chegg. My daughter actually has had a geometry packet. She only had one page done of, and she said, "Well, I need help. I need help." And so I went down to help her the next day. She said, "Oh, I got it." I said, "Really?" Yeah, her teacher just printed her a packet offline, so she found all the answers offline, probably on the same website that her teacher printed her the packet off of. So, I mean, I know stuff is out there, and I'm not going to say that I blame you for using all your resources on a test, but that's not the point of a test. So, we'll have to do
Do
what?
we like upload or do
I
we
plan
like
on just uploading a
do we
PDF.
upload our tests to get credit for work?
Absolutely. I'll have you just send me your work just like you would written. The only
Okay,
difference
it sounded
between it
like we were
being
inserting into a box or something like that, and it's right or wrong.
No, I tried to set up a test like that last week for calculus, and every thing I tried to put in Blackboard, thank you, honey. Everything I tried to put in Blackboard, it wouldn't do the font right. I mean, wouldn't even do an exponent, let alone a integration sign or anything like that. So that's not going to be an option. It's going to have a PDF uploaded, and you will have to send me your work within so much time of closing out. I mean, if there's a 2-hour time limit, you're going to have to send me your work relatively quickly after closing out. You can either take a picture of it and send it onto my cell phone. You can upload it to Blackboard as an attachment. You can send it to email as an attachment. I really don't care how you send it to me, but I'll need your work. And then I'll probably just write on it and send it back to you. I mean, it's going to suck for me because I'll have to change every single test because I'm going to send you your work back with feedback on it. So not only will you have all your work back, but you'll have all the questions, all the answers, all the work. So it's going to suck for me because I'll have to redo every single test in the long run. But so that's fine. I don't care. It's not a big deal.
So, like, what if we have questions on our test? How are we going to ask you?
Well, ideally, I would like to set up a Zoom session during your class time, but you can't all be on it because you can't all be asking questions on your test. So at the same time. So what I was thinking about was having but then you're in a lockdown browser, but you can't. You're just going to have to call me, I guess. I put my cell on Blackboard. I'll send it out again. Well, I'll tell you, it's 214-1277. So if you have to call me if something happens and you got to ask an emergency type question, that's really all I know to do. I planned on having a big chunk of time though, like 7 a.m. to noon or something like that. So you didn't have to be on it at exactly the same time. And I'm guessing by the looks of only having 7 of you here, probably we're going to have to take it off to Friday because I know a couple people work every Friday. So, and the ones that have switched schedules because of all the crazy and have been working on Mondays and Wednesdays also, I just may have to do an individual session with them at a different time or make a different test, which I really don't want to do, or just tell them, look, this is our class time. Unless you're at work, you've got to be there. So I don't know. We'll be flexible. You didn't sign up for all this shit. Nobody did. So I can't really hold you to requiring an online portion that's like strict and crazy. So, all right. Any other housekeeping things? And how is homework going? I know some of you are doing one new section and trying to get caught up in one old section at a time. It looks like I was hoping next Friday would be that test, but I think we'll push it to the next Monday because I don't really want it on a Friday. I mean, or for that matter, if everybody's available on a Sunday afternoon, we could just do it then too. But I don't know. We can talk about that. Any other issues going on?
I said, what about like our last test? You said we could have gone over it for extra credit points. And
Yeah,
obviously,
well, it's in my desk drawer, and I can't get it. They're not letting anybody on campus. So by the end of this, it'd be nice if by the end of the semester we could get in there, and then I could get it and we could go over it before the final. I'm not sure that that's going to happen. I heard on NPR this morning that China has put on or kept on their lockdown because even though they're 6 weeks past their peak, they're expecting a second wave. And I imagine that we'll end up doing the same thing here. In fact, they're discussing moving all non-lab courses and non-hands-on courses, even summer courses, to the online environment, and either having like calling it a Zoom class and just meeting like this, or strictly online, just to keep people off campus and not like major lockdown, stay home, but taking restrictions off slowly. Dr. Becker said she just has a feeling that they're going to push this wave into the summer, and then she said we'll be right back where we are now, scrambling to adjust. So they may just go ahead for classes, regular classes that don't have a lab component, and just put them online anyway. Maybe limit lab component classes to 10 or fewer students. I mean, I don't know how many science classes have in the summer, but I don't ever have like an overwhelming amount of students in any one class. So. And she did say, if you're interested, that we would be having a graduation ceremony. I'm going to assume that would be pushed back into the summertime sometime. So for those of you whose mamas are insisting that you walk, which I would be one of those mamas, tell them that they'll be in luck, because it looks like we're going to have at least something.
not if this thing gets pushed back.
What? Well, why can't we have it in August? We could have it outside and have it in the parking lot and 6 feet between every chair, I suppose. I don't know. I don't know what the plan is, but maybe she's just being hopeful.
A Zoom
Anywho.
lecture,
Huh?
a Zoom graduation.
Yeah, maybe. I saw something on the news about a Zoom prom. Everybody dressed up and got on Zoom so they could see each other. Seems like a waste of makeup and hair to me. As you can see, I didn't make it to makeup or hair this morning. Sorry about
That's how you prevent teenage pregnancy right there.
that. No proms. I thought it was letting kids come and babysit the twins. I mean, that's always how I sold my babysitters. I paid them well, $10 an hour. That's pretty steep for babysitting. And I told their parents, well, I mean, you got to look at it this way. It's birth control built in, because after a couple evenings with the twins a week, nobody's going to take any risks. Trust me. Of course, they're bigger now, so that doesn't work quite so well. All right. Anybody else got anything to share? Any word from Edwardsville, guys, on summer? I can't remember who's all in that class. Nick Miller, I know, has to. Blake, did you have to take that class? Jordan, somebody
No.
has to.
I didn't.
Oh, all right. Well, maybe I'm just crazy. Maybe it's just Nick. Anyway, I guess you haven't heard anything from him. All right. So section 5, the annihilator approach, is just about the same as the last one that we did. There's just a little bit different with it, but it's the same idea. The difference with the annihilator approach is that it does not, let me turn the computer back on, there we go. You guys still there?
Yeah. Hey, is our test going to be over 3 and 4?
Where did the last one stop at?
I don't remember. I think 2.
Oh, we already tested over 3. It was just 4.
That's what I thought. And 4 is
Yep.
really long.
Yeah, I
Yeah, because
agree.
the 4 test is really long. Yeah.
Did we test over 3? I don't think we did test over 3.
I
There was
believe
only
so.
a setup.
I thought we
The
did.
word problem on the last test was a setup. It was off
I'm
section
pretty
1.
sure we did.
Okay, I don't think so. I thought it was 1. It'd be wrong. It is. It'll just be a thing or 2. And you will have, and I had to put that too, like in the response monitor when I was practicing. I had to change all the directions, like for if you had paper out for a note, like your list of things for chapter 3, your list of equations, and then also like I don't think that they have a physical person, but I don't want you guys to be confused on what you have. And the only person that checks like that check around thing, I guess the computer flags if there's lots of crazy stuff going on and it won't let you in. But once you're in, the only person that sees the video is me. I don't even think that they can access it to look at it. But anyway, oh, and you know, I have a test with 101 this Thursday on Respondus Monitor, and it's already set up through Alex. So I will get to check it out with them first. So maybe it'd be a good idea to not have your test on Friday and wait till I see how it goes with them first. And I might change my mind, but I think it'll be okay. I'm really not crazy concerned. All right, this one is called the annihilator approach because it wipes out everything. It turns it into a 0. And once you have it as equal to 0, it makes it homogeneous. And then you only have to do that complementary equation part. So that's the goal of this one. So remember on the other approach where you had unknown constant coefficients, you made a guess at the answer, and it was always one of those ones that wrapped around. Like if it was a polynomial, since it breaks down, your guess would be an ax squared plus bx plus c. It was a second degree polynomial. And if it was an e to the x, you would have a piece of an e to the x. And if it was a sine, you'd have a sine piece and a cosine piece, and then combinations of those. And the annihilator approach really works for the same thing. The benefit of the annihilator approach over the other two, or the other one, is that you don't have to worry about that forgetting if there is a repeat or not, because it's inherent within the approach that you're going to see if there are repeats. The other weird thing about the annihilator approach is it uses a notation that you have probably never seen, and that's called a differential operator. It's just a capital D, and it's not a variable. It's not a constant. It's an operator because it actually does something. So D sub y means the differential operator on y, which is another name for the derivative of y. So if the notation looks like this means the differential operator on the cosine of 4x, which means what's the derivative of the cosine of 4x? And here it is. Differential operator on this fellow means what's his derivative, and here it is. And it's kind of hard to remember that because we have so many constants running around and it kind of looks like it could be a constant. So you're going to have to remember that's your differential operator. Second order derivative means differential operator twice. Do the differential operator on y and then do it again. Just like an exponent would mean multiply it times itself 2 times. And sometimes we leave the of y part off and just put the d squared. Just like sometimes when it's f of x, I mean, sometimes we leave the f off and just, or the x off and just call it a function f. So that would be no different than that. All right, so these boxes you would have on a test, the operator derivative to a power, which means the first, second, third, fourth, fifth derivative will annihilate or take down to zero. When you get do the derivatives, you're going to end up with a zero after doing n number of derivatives if you have powers of x. For example, if you have an x to the third, to get down to a zero, it's going to take a fourth derivative to wipe out that whole term. And the fourth derivative. So any powers you have, you look at the biggest one, and you're going to need one more derivative than that. If you have an e to a power and an x power, 0 power, so it still counts. Derivative minus alpha. Alpha is this power on the e. And then the n on this one is also one n more than your highest power of x. And this is assuming all of those e's to the powers are the same powers. They have to all be alpha x's. If there's more than one, you'll have to do more than one d minus alpha to the n. And we'll talk about that when we get to some examples. Then, if you have an e combined with a cosine or a sine, you've got this alpha with the e on all of them, and it's going to go here. And you've got this beta with the sines and the cosines. Remember, those have to be the same. It's going to go here. So there's your alpha and your beta. So you plug all those numbers in. And then your n is, again, one more than the highest power of your x on these fellas. And this is going to be looking kind of weird. It's going to make you feel like a polynomial, and you're going to have some foiling out, and it's kind of like, looks like the distributive property, but I'll show you when we get to some examples, so it makes more sense. Everybody okay so far? All right, question number 1. Find a differential operator that annihilates the given function. This is a polynomial. The biggest power of the polynomial is 3, so it's going to take 4 derivatives. So the differential operator is d to the 4th. The first derivative would be negative 10x plus 24x to the second. The second derivative you could do, the third derivative you could do, the fourth derivative would be down to 0. You could work all those out if you wanted. Next one is e to a power. So that's my second box, e to a power. That does not have an x, so we're talking about this fella right here. The alpha is a negative 3. So the differential operator will be d minus alpha minus negative 3 will be a plus 3. And the exponent is 1 more than the exponent on the x term. So that's going to be to the first power. So the differential operator is d plus 3. Now, if I was going to ask you to show that d plus 3 was a differential operator, or find it and show it, and this is what that would look like. Can I get a new page in there?
Can you repeat that again? I'm kind of confused on how we got that.
Yep. There's my new page. All right.
Kind of wasn't paying attention whenever you described the.
It's kind of hard to pay attention when I'm not looking at you, right? You can find all kinds of other things to do. You want to go over this box again, or you want to go over that problem again?
Both real quick if we can.
Okay. All right, so if you have e to a power, you can have an x with it or not. If you don't have an x with it, it's automatically x to the 0 anyway. So you really always have an x with it, x to the 0, x to the 1, x to the 2, and so on. So we do have e to a power, and the power on the e is a negative 3, and that is the alpha piece. So that's the negative 3. So the negative 3 goes here. So the differential operator is D minus a negative 3, which is D plus 3. And the n is one more x to 0. So one more. Nick?
This is Elliot. Your internet's really bad.
Yeah, your audio is cutting out a lot.
A lot.
You
It's
sound
half
like
the
a
reason I
robot.
don't know what's going on.
Okay. Well, I turned off the other device I have. Let me make sure the voice did not connect the TV. What are you doing? Oh, you're not on the TV? Okay. Just make sure you weren't on the TV because the internet's wanky. The internet that I'm on. Bye. Okay, bye. I let him watch Toy Story 4 the other night when I wasn't using it. Okay, what about now? Is it okay now?
Yeah, that came through clear.
Anybody? Better? Okay. All right, so let me try that again. The power on the X is 0, the highest power. So this 1 is because it's 1 more than the 0 on the X because there's no X there. And then the alpha is -3, and so it's D plus 3. Still okay?
So in the problem, there's just like an x to the 1 power.
Well, there's an X to the 0 power automatically if there's no X, because X to the 0 would be 1. And so if there's no X, you can just remember that it's just the D plus or minus the alpha, depending on if it's positive or negative. All right, so this is why it works. D plus 3. This is a differential operator on e to the -3x. And it is like a distributive property. This is called the differential operator on e to the -3x. And then the next piece is got to be a 3 times e to the -3x. And if you operate and do the differential, do the derivative of e to the -3x, you get -3 e to the -3x. And so, of course, those cancel, and that side has been annihilated. So that's why that setup works with the d plus alpha to the power. Still okay on the internet? Or is it going crazy?
I have no idea what you just said.
You guys still there? You weren't. What about now? Can you hear me now?
Yeah.
Now I can hear you.
Yeah.
It's still in and out.
Okay. Saying they gave me 2 different things, and they didn't tell me which one to use. They said they both work fine. One of them says K, one of them says 5 and 2.4 GHX, and the other one says 5. Which one's going to be better?
How close is your hotspot?
3 inches from my computer.
Use the 5.
Okay.
But can you put your like hotspot in the window or something in the direction of the closest cell tower?
I mean, the window is like 3 feet from me, and it's
Perfect.
right out the window, so it should be fine. I mean, the cell tower's not right out the window, but it should be close. I haven't had this problem before. Let's
It's
see.
kind
I
of
have to
bad.
somehow get to the other internet. let's try this one then. All right, what about now?
I mean, we really won't know until you get going.
Okay, so, but I didn't lose you, I mean, it switched over, but I wanted to make sure you weren't like non-existent. Okay, so the next one is 4e to the 2x. And 4e to the 2x, that's the power is x to the 0, so we don't need to worry about that. The alpha is 2. So this is going to take a d minus 2 to the first power. If it was just that. If it was this one by itself, it would take a d minus 2 again because your alpha is still 2. But this time, since the power of x is 1, you've got to bump it up a notch to d minus 2 squared. So to annihilate the pink one, it would take a d minus 2. To annihilate the red one, it would
Hello?
Mrs. Elliott, are you there? Because it does not seem like you are there. Hello? Mrs. Elliott. It's the apocalypse, boys.
Did you just leave?
I just got back, yeah. It
What
kicked me
happened?
completely off. I lost it totally. All right, I'm going to put on my personal hotspot and see if I can.
Cancel class.
Huh?
Cancel class.
I mean, I could cancel and I could do right, or I could put up a video later.
No,
if
I'm
this
not sure
doesn't
how
work.
you're I don't know how you're doing everything. Like how like the D minus the alphas or and then I still missed that part. I think it was glitching.
You should do an internet speed test. Do you know how to do that? Can you even hear me? Probably not. Okay.
You're
Good talk.
telling me I complained for no reason now? Doing even in?
No. What? I said, so I need to start over. I'm asking you if I need to start over because you didn't get anything.
Kinda. Just that part again. Just the box.
Okay. All right. For just C or for all of them?
I mean, yeah, I guess you can just do it for the last one, but just can you explain the box again, please?
The whole box or just the middle box that we're using at this time?
The one that we're using at this time.
Okay. So the
Well,
middle, the top box is good with the powers of
Are
X's.
you sharing your screen?
Oh shit, no.
Hey, don't say that here.
I know, I'm sorry. I'm frustrated.
This is why her voice is so clear and beautiful. It's because she's not sharing her screen, and that takes bandwidth.
Well, I switched to my hotspot, so I don't know how long we'll go and we'll run out, but we'll see. All right, you got screen?
Yep.
All righty. Okay. So the middle box is if you have E's only. What's going to go in here is whatever power is on your E, and it's the opposite sign because if it's e to the 2x, it'll be d minus 2. And the only other thing you have to determine is one higher than the highest power of x that you have. Okay, so in this last one on C, if it was only this chunk here, I would only need a D minus 2 because the power on E is the 2. And since there's no X, it's X to the 0. So increase it by 1 to X to the first. N is 1. Done. D minus 2. We'll wipe that whole piece out to 0. But it won't take care of the other piece. This piece, you would need a D minus 2 because the alpha is a 2. This time the power on X is a 1. So you have to increase that to a squared. So the D minus 2, that would be a second derivative. That would wipe out the 10 piece. But it would also wipe out the red piece because these guys are one and the same. You're just doing a second round of the same thing. So it would be like saying an X to the third takes 4 derivatives to wipe it out, and an X squared takes 3 derivatives to wipe it out. So obviously the fourth derivative is going to take care of that one also. You don't need to do a fourth derivative and a third derivative and get a seventh derivative to take care of both of them. Any of the smaller ones will work. And that's really what the box says also. You have to look at the biggest because it will annihilate each of the lower ones also. So that's a D minus 2 to the second power. How is the sound now?
Great.
Great? Okay, good. Must be Sprint this morning. So that is D minus 2 to the second power, just to verify that we have the correct annihilator, saying that's going to annihilate 4 e to the 2x minus 10x e to the 2x. All right, so it's going to work like a FOIL. On the left, I have a d squared minus 4d plus 4, and that's going to operate on 4 e to the 2x minus 10x e to the 2x. That's going to be a second derivative of all this, minus 4 times the first derivative of all this, plus 4 times all of this. So we're going to need a first and second derivative. Let's colors go. The first derivative, I'm just going to call it y prime. There's no y in here, but I need a name short. So y prime, the derivative would be 4 e to the 2x times 2. For the second part, I would need a product rule. First times the derivative of the second plus second times the derivative of the first. That would be an 8 e to the 2x minus 20x e to the 2x minus 10 e to the 2x. So a negative 2 e to the 2x minus 20x e to the 2x. There's your first derivative. Second derivative would be, go again, that would be a negative 2 e to the 2x times 2. This one is a product rule also. First times the derivative of the second plus the second times the derivative of the first. Is this the first day the audio's been bad? Because I can try to figure out how I can record from my machine, because I'm assuming if I record from my machine, it wouldn't be cutting out.
Usually it cuts out just a little bit, but you can still kind of hear what it's saying.
Just a little bit.
Okay, but today's the first time. All right, so there's your second derivative.
So why are we doing these derivatives?
I just want to show that it actually annihilates, that I got it right. I want to double check I did the correct thing to annihilate. So first things first, the second derivative operating on whatever my y equals is. So my second derivative is negative 24 e to the 2x minus 40 x e to the 2x. Then next I have a minus 4 times the first derivative of this fella. So minus 4 times this guy. So that's going to be an 8 e to the 2x and an 80x e to the 2x. And then last but not least, I've just got the 4 times this guy. So that's 4 times the regular fella. That's going to be 16 e to the 2x minus 40x e to the 2x. And that should all cancel out nicely. Looks like it does, because I'm saying this is the annihilator. So d minus 2 quantity squared is supposed to wipe the function out to have no value. 2 negative 40s and a positive 80 will cancel. 8 and 16s are 24 minus the 24. And yep, it wipes it completely out. And obviously not today, since today's been crazy, but Monday we'll work on like the process of using an annihilator to solve a differential equation. Looks like we're only going to get to the annihilator portion today. All right, so that's the correct one, the correct annihilator for that piece.
So that's kind of like the M equation.
What is what?
So
Say
that's
that
kind of
again?
like the M equation that we have.
Well, what's going to happen is we're going to have equals of g of x over here. And so what we're going to do is we're going to operate on both sides with the annihilator so we can make this side knock itself down to 0. So that's the goal. So we'll be finding what annihilates that extra g of x piece. And then the process is from there on out is kind of similar to the last one, where you have to solve for the A, B's, and C's and D's. Unfortunately, it still has the big, long, terrible system of equations at the end. Yay! All right, this last one down here, example 2, we're into the bottom box. So the bottom box has pieces of e to powers and cosines of sines with the same angle in them. If they didn't have the same angle in them, we would have to end up doing like a couple different chunks of annihilators. Like say you had a sine of 2x and a cosine of 3x, and they didn't have any e's to them. Well, if they didn't have any e's to them, then your alpha would be 0 if they didn't have an e, because that would, oh yeah, alpha e to the 0 would be 1. So alpha could be nothing if that part is not there. So this will take care of a plane sine and cosine also. So for the sine one, we would need a second derivative minus 2. The alpha is 0, so that piece is not there. Be 0. The beta for the sine one would be a 4, because 2 squared is 4. And so then the power of n would be the x in the front, and there's no x in the front, so that's also x to the 0. So that n is 1 higher than that, so it would be a first power. So you would need a d squared plus 4 to take care of the sine of 2x. But then you'd have to have the cosine of 3x. And for that one, you would need a d squared plus 9. And so you would have to have both of them to annihilate. But since these are both 2x's, we're only going to have to run through one piece because the angles are the same. So those angles have to be the same. And we'll do some more examples later of what happens when you mix some of these things together. But those angles have to be the same. All right, so
But hold
the,
up, Mrs. Elliott. Why did you say, I'm still confused on how to get this annihilator part. Why did you say that the alpha was 0? Shouldn't it have been -1?
why did I say that again? Why did I say what was 1?
You said that the alpha was 0, and shouldn't it have been -1?
No, not on this one. I meant I was just making up one if there was 2 different angles. It would take 2
Oh.
different things to do. No, not on this one. Yes, on this one, the alpha is 1. And since there is no x to a power, the n is 1. If there's no x, it'll always be 1. If it's x to the first, you'll bump it up to 2. If it's x cubed, you'll bump it up to 4. It'll be 1 more than that. And the beta is going to be the angle. And the angle is 2. So it's a d squared plus the alpha. No, what is it? I can't be on 2 pages at once. Minus 2 alpha d. Minus 2 alpha d. Oh, it's always d squared. Minus 2 alpha d plus alpha squared plus beta squared to the nth. And I didn't get my negative. Alpha is a -1. Pretty sure I said negative, but all right. Plug everything in and you've got your annihilator. D squared plus 2d plus 1 plus 4 is 5. Plus 5 to the first power. That should annihilate, in other words, wipe out to 0 all of this fella. So to double check it, we're going to do the second derivative and make sure it actually works. First derivative would be first times the derivative of the second. Derivative of cosine is negative sine and a chain rule. Plus the second times the derivative of the first. And then the 9 part. Minus 9 e to the negative x. Derivative of sine will be a sine of 2x will be a 2. Cosine of 2x plus the second times the derivative of the first will be a positive 9 now, e to the negative x. Which I hope I got some like terms here to go together. Should have some. This is a -10 e to the negative x sine of 2x, and this is a positive 9. So that would make a -1, I guess. E to the negative x sine of 2x. And then the other two like terms, -5 and -18. So that'd be a -23. But I need more than just a first derivative because d squared means I have to do the derivative twice, the differential operator. So here comes the second derivative. First times the derivative of the second. That's the second. It's the derivative of the first. First times the derivative of the second. Second derivative of the first. So that one's going to be like terms again, I'm sure. This is a -2 with the cosine. This is a positive 23 with the cosine. So that's going to be a 21 e to the negative x cosine of 2x. And then these other fellas, 1 and a positive 46. 1 and 46 will be a 47. Now that's supposed to annihilate. The second derivative plus 2 times the first plus 5 is supposed to annihilate my function. So let's double check. The second derivative is that 21 fella. All right, second derivative plus 2 times the first derivative. Well, that's going to be right about here. So that's going to be a negative 2 e to the negative x sine of 2x minus 46 e to the negative x cosine of 2x plus 5. What I have a lot of people on the plus 5 do is just put plus 5, but this is the differential operator. It's operating on this guy. So it's the second derivative of the function plus 2 times the derivative of the function plus 5 times the function. You have to remember to do the 5 times the regular function as well. And the regular function, when I multiply it by 5, is going to be a 25 e to the negative x cosine of 2x. And the regular function was a minus 9, so when I multiply that by 5, it's going to be a minus 45 e to the negative x sine of 2x. And you can see that all of those terms cancel, leaving you a 0. We have double checked, in fact, that d squared plus 2d plus 5 does annihilate our function. All right, what do you think?
So that part we just did at the end is like the same exact part, or like the same exact thing we just did.
That's just to double check that this is in fact right. You know, on the, what is it? The integrating factor, I always tell you like the left side is going to turn into the product rule, and I like to double check it before I go any farther to make sure I didn't make a mistake. Because if I did make a mistake and I got all the way to the end, my gosh, if it was a crazy integration, I'd be so mad because I did the wrong thing from the beginning. That's the same thing here. The annihilator is going to work if you use the charts right. But if you want to double check it before you get into a super nasty A, B, C, D, E, F, G solve, it wouldn't hurt for sure, because if you go down a road that's going to take you some crazy back roads and it was for the wrong setup, you're going to not be happy. So, I mean, that's up to you when you get to some, if you're actually going to check that the annihilator that you picked works. Now, there are some instances where you're going to have to, and that would be if I said show, verify, or prove that blah, blah, blah annihilates blah, blah, blah. So you'd have to show that that annihilator takes you down to 0 when you use it. All right, we're going to put all this shebang together. So here it is. This could be done with the guess and check from the chart, like section 4. With the 4x squared, you would pick an ax squared plus bx plus c, and you'd solve for a, b, and c. And in fact, this is going to turn out really similar to that. These approaches are very close to the same. But the first is always to do the auxiliary equation. So the auxiliary equation first still needs to be done. But on this one, you really can't forget to do it because it's part of the process. And you know, you get your -1 and your -2, and that gives you a complementary solution of C1 e to the negative x plus C2 e to the negative 2x. Old news. I hope you can do those in your sleep by now. All right, we are talking about a power of 2. What annihilates a power of 2? What derivative takes 4x squared down to a 0? Well, that's going to be a third derivative. And you don't even need a chart for that. Of course, you know that a third derivative is going to take a polynomial of degree 2 down to 0. First derivative would be 8x, next derivative would be 8, third derivative would be 0. So what you're going to do with that third derivative is operate on both sides by that third derivative. So you're going to operate on the left side of your original equation with the third derivative, and you're going to operate on the right side of that equation with your third derivative. And then you're going to simplify. On the right side, the third derivative of 4x squared, well, that's going to be 0. That's why it's called the annihilator approach. It wipes it out to 0. On the left side, you're going to simply rewrite these and combine them into the same format. This is the third derivative operating on the second derivative of y. And the third derivative operating on the second derivative of y is going to be the fifth derivative of y. And this is the third derivative operating on 3 times the first derivative of y. So this is going to be really 3 times the fourth derivative of y. And the last one is going to be the third derivative operating on y. The third derivative operating on 2 times y, actually. So you're going to write it a 2 times the third derivative, and all of these now are operating on y. And then you're going to solve that auxiliary equation, which is why you're really not going to distribute here. You're going to really keep it separately because you're going to turn around and solve this auxiliary equation. And the first step to solving it is to take that d to the third, which is now an m to the third that you distributed in, and turn back around and factor it back out. And if this seems familiar, it should, because there's part of your auxiliary equation right there. Find your zeros. 0, 0, 0, -2, and -1. That is going to be the format of your final answer, y. Your general form comes from that format. For the first for the first 0, we have a C1, e to the 0x. For the next 0, we have a C2, e to the 0x, but slide in an x because it's a repeat. For the third 0, C3, e to the 0x, slide in an extra x, but it's still a repeat, slide in an extra x, plus C4, e to the -2x, plus C5, e to the -x. that is what your general solution is going to look like. Now remember from our last process, the general solution is always made up of the complementary solution plus the particular solution. You find your complementary solution by pretending it's an equal to 0, solving the auxiliary equation, and then you make a guess at your particular solution, ax squared plus bx plus c. Then you solve your particular, then you get your ABCs, then you put it together. Well, this is the same thing. This is still general solution. The general solution is still made up of a particular solution and a complementary solution. And I already knew what the complementary solution was right up here. So this portion is your complementary solution, which leaves your particular solution to be right here. So here is that particular solution. And just like the last time, that has to be solved for. So if you were not doing the annihilator approach, if you were doing the guess, you would have guessed ax squared plus bx plus c based on the fact that it's a 4x squared anyway. So the annihilator approach in this instance makes it seem like it's longer, but that's because there are no repeats when you go to work the ax squared plus bx plus c out. Doesn't repeat here. And so there's no extra pieces to slide in that you might forget about. When you do the annihilator approach, there are no extra pieces to worry about. You're going to already have your y of c. You're going to set it aside. You're going to know exactly what this y of p is without having to think, oh shoot, were there any extras in there I'm going to have to slide in extra x's for? Because you would have already in this part slid in the extras. So how do you finish? The exact same way you finish section 4.4 with the unknown coefficients. And before we do that, does anybody have a question? My goodness, I hope you're all there and I haven't been talking to myself. Somebody speak, please.
Yeah, we're here.
Oh, thank goodness.
God dang it, Blake.
How long are you going to leave me out before I say anything? I was about to cry. Thank you, Blake, you sweet thing. Okay, so my initial,
Thanks,
I'm not
Mom.
gonna, I am not carrying on any subscripted A, B's, and C's. If I subscript the A, B's, and C's, I'm gonna be in serious trouble. I'm gonna assume that some of you printed the pre-printed notes. I'm gonna work my way up instead of down for my A, B's, and C's here. So I gotta find out what these A, B's, and C's are, and I'm gonna be good to go. How do I do that? Same way I did in the last section. We are going to plug into the original equation, which is the second derivative plus 3 times the first derivative plus 2y. So I'm going to need 2 derivatives out of this thing. B plus 2cx. Second derivative is 2c. And so when I'm ready to plug in, it's going to be the second derivative first, which is 2c, plus 3 times the first derivative, plus 2 times y, and that's supposed to be equal to 4x squared. I didn't line these up this time. Sometimes if it's a short one, I do like to just kind of piece it together. So let's see here. My x squared piece is only going to be here. So 2C is going to be 4. My plain X piece is going to be here, 2B. And here's another plain X piece, plus 3, plus 6C. And there's no plain X piece on the other side, so that's going to have to be 0. And then my constant term is going to be a 2C and a 2A. And there's no constant term either, so that's going to have to be 0. And so I just solve that system and I get lucky. I mean, A, B's, and C's, it could be a system of 3 equations and 3 unknowns, and you have to actually work hard to solve it, which this one's easy because one of them comes out right away. If it doesn't, don't be surprised if you have to solve a system eventually on something. What's that? -2 for A. I'm feeling like that's, yeah, that's right. And then, oh, I missed a constant part, didn't I?
What happened to the 3B?
I left it off. Oops. There it is. Oh, dang. So now this is going to be a 4 here because 2 times C is 4. So I do have a little bitty equation to solve here. 2A plus 3B equals -4. And if I combine that with my pink, oh no, I don't need to do that to combine it with my pink. I can get my B already, can I? 2B plus 12 because I know C. So B equals -2. And then I can just put that one over in as well. If B is 2, that fellow right there is going to have to be a 6.
B equals -2.
Yep, nice save, thank you. So -6, so that'll be a 2A equals -2, move to the other side, +2, A equals 1.
Wait, isn't B 6?
Oh my goodness. Guess what? This is the last question
Or
I'm
a
doing
negative
today.
6?
Yes. Ooh, which
Idiot.
makes this a -18. Which makes that a -14. So that makes that a +14 and a 7. Struggle is real today. Final answer. Head at the bottom of the last page. It was right here in green. Except now I have everything I need to put in. I have my A and my B and my C. And those were going to be 7, -6, and 2. And that's it, unless you're given initial conditions. If you are given initial conditions, then in addition to doing all of that, you have to go right on back and solve for that C1 and C2. Excuse me, I mean C4 and C5, and if you want to switch them back to 1s and 2s, it's whatever. But you got to go back and solve for those. If you have initial conditions, you'd have to plug in. So really kind of the same grand finale, just a little bit different to start with that annihilator. Nick, are you feeling better about these box fellas here? Oh, and I gave you a nice little list here. The steps for the
I
annihilator.
still don't understand the annihilator.
You mean getting the piece that you're doing?
Yeah.
Well,
But why does it say like to even find n? It's like n minus 1.
well, when you're picking the, okay, so if there's no e to the x's and there's no sines and cosines, it's always going to be x to a power. And whatever powers of x's you have, the annihilator is going to be one more than that. So if your biggest x is an x cubed, your annihilator will be a fourth derivative. If your biggest x is x squared, your annihilator would be a third derivative.
And that's for polynomials, right?
Yes. Any powers of x's combined together. So that makes polynomials only. If you have no sines and cosines, but you have e to the x's with or without a polynomial, because without the x piece, it's just like x to the 0 power. So technically, that piece could be x to the 0 e to the alpha x. So even if there's not a power of x, you can still use this middle box. So it's always going to be a d minus whatever that power of on the e is. And then you have to determine your largest x. If there's not one, it's x to the 0. So that would be a power of 1. If there is one, say it's x squared, that's got to be bumped up by 1, and it would be the third power then, because this and this differ by 1. They bump up by 1. And then on the bottom box, the same, you can have all of them on the bottom box. If you have sines and cosines, you're in the bottom box. Now it's possible, like this one still has an x to the 0 on it. So it's possible that you don't have any x because it's x to the 0. It's also possible that you don't have any e to the alpha x's because it could be e to the 0 x. So if it's just sines and cosines, your alpha would be 0 and your n would be 1 because n minus 1 would be 0. So it's possible that you don't have any of those. And so this piece wouldn't be here, this wouldn't be here, and it'd just be a d squared plus beta squared. So you just gotta kind of figure out where your parts fit in, how they fit together.
Okay. Probably whenever we do more solutions or do more problems, I'll pick it up.
never
I kind
what?
of get it a little more now.
Okay.
I
I
just need
think
to see it.
Yeah, you just gotta practice it. And we'll do, I think there's 4 more to do on Monday, so. All right, sorry about all the internet trouble today. Cole, I don't know if you want to cut some of that. I don't even know if it's possible to cut recordings. I obviously don't know how.
It is, but it's a lot of work and it's not worth it.
Okay, well, don't do it.
Yeah,
All
we'll
right,
just
sounds
upload
good
it
to
as
me.
it is.
Sounds good. They can fast forward through whatever they don't want. All right, let's see. Who else made it in? How many people we have here today? Oh, good. Dakota made it today. Got Dakota. Dakota and Chase, we had some conversation at the beginning about some Respondus monitor.
The what?
The Respondus monitor, we're going to do a lockdown browser for testing. They're adding it to Blackboard, but I don't have all the specifics just yet.